The derivative can provide information on a function, including the intervals on which it's increasing or decreasing. So if we look at the interval from a to b, the derivative is less than 0, so the slope of the tangent to the curve of the function is negative, and therefore the function is decreasing over this interval. And from b to c, the derivative is positive, so the function is increasing. And from c to d, the derivative is negative, so the function is decreasing. And so on. So the function increases after d. Now where the derivative is 0, the function has critical points, where it changes direction. And where the slope of the tangent to the curve of the derivative is 0, that means the second derivative is 0. And that's where the function has inflection points, where it changes curvature, from concave up to concave down and vice versa. The first derivative test can be used to find local or relative extrema of a function. So if y is a function of x, then what we do is differentiate it, assuming it's differentiable, and then set the derivative to 0. And that will give us the x value with the local extrema or critical points are. Because we're just basically testing the points where the slope of the tangent to the curve is 0. Also, if we test the derivative in the vicinity of these points, so to the left and to the right, then without using the second derivative, we can identify whether the critical point is a minimum or a maximum. So on the left, the derivative is greater than 0, and on the right, it's less than 0. So this is a local maximum, and here we have the derivative being less than 0, and to the right it's greater than 0, so this is a local minimum. Let's use the first derivative test to find the critical point, and also use the derivative to justify why the function is increasing or decreasing along different intervals. Well, the derivative of this function is equal to 2 by x minus 1, and if you set that equal to 0, the x value where the slope of the tangent to the curve is 0 is equal to 1. And then substituting x equals 1 into our original function, then y of 1 is equal to 3. So that's our critical point. And we can also observe from the derivative that for x is less than 1, then the slope of the tangent to the curve is negative, and therefore the function is decreasing. And for x greater than 1, we can see that the slope of the tangent to the curve is positive, and therefore the function is increasing.